All right, let's see. We'll start with question 6. Oh, we're on the practice exam now. The window closed on homework. I'm sorry, Nadia. So question 6, they give us, unfortunately, the way this splits it is split it on 2 different pages, but they gave us A to B. A to 2B is 456. So I've got A to 2B, the delta H equals 456.7 kilojoules, right? And then the other reaction is A goes to C, and they tell us that delta H is minus 22, right? So this is Hess's law. Ultimately, they're looking for, we want to know 2B goes to C. All right, that's delta H we don't know. And yeah, Mike, I'll add 21 to the list. So we want to know delta H for this reaction. Well, I'm just going to flip that top reaction. That gives me 2B goes to A. That flips the delta H to a negative 456.7 kilojoules. All right, now I can add them together and A cancels out. I get 2B goes to C. I get a delta H of minus 478.8 kilojoules, or choice A for question 6. All right, so Hess's law. We can flip those, we can multiply, we can divide those. So 1 down. Question 8, right, propane reacts with oxygen, blah, blah, blah. If this many grams of water were produced in this reaction, how many grams of oxygen were consumed? So my numbers might be a little bit different than yours. And sorry for not zooming in earlier. That would have probably made it a little bit easier to see. All right, I've got 13 grams of water. I know that water is 18.02 grams per 1 mole. All right, I can find moles of water because basically I need to go from grams of water to moles of water. Once I've got moles of water, I can use the mole ratio to find moles of oxygen, and then I can find grams of oxygen. So the first step, right, 13 grams divided by 18.02 grams per mole, got 0.72 moles of water. Yes, I'm keeping more numbers in my calculator, but the next step, I want to go from moles of water to moles of oxygen. So I know for every 4 moles of water that I make, I've got to put in 5 moles of oxygen. So 5 moles of O2 over 4 moles of H2O. So multiply that by 5 over 4. And I get 0.9 moles of oxygen. The last step is to find mass of oxygen, right? Oxygen is 16, so O2 is 32 grams per mole. So multiply that by 32, and I get 28.85 grams of oxygen. 2 significant figures because our mass is 2 significant figures. So I'd say 2.9 e to the 1 grams of oxygen. 100%, you're going to see a question like this on your exam. We're all set with that? Oh yeah, question 10. Whoever asked question 10. Question 10, that took a bit of time to work through. So yeah, that was a good one to ask. So we've got the thermite reaction, right? Aluminum reacts with, I'm just looking for my thermite, or the aluminum reaction. Aluminum reacts with iron 3 oxides, produce aluminum oxide, iron. How many grams of aluminum 3 oxide can be made? Just see if I can find my answer key here so I can look up the masses, save us some time. Yeah, I'll take a look at 9 and jump back. All right, so they give us mass in grams. I've got aluminum, 48 grams of aluminum. Have to do the same calculations, right? So limiting reagent calculation. I have to convert everything to moles first. So I know, right, 1 mole of aluminum, I go to the periodic table, aluminum is 26.98 grams. So I've got 1.779 moles of aluminum. Do the same thing with the iron 3 oxide, right? Iron 3 oxide, and that's why I wanted to look up my answer key that I worked through, so I didn't have to look up these smaller masses. Iron 3 oxide is 159.69 grams per mole, so I have 1.409 moles of iron 3 oxide. So here's where I did something a little bit different with this question, just to make it a little bit faster in some regards. So I've got moles of aluminum, I've got moles of iron 3 oxide. I'm asked to find the limiting reagent and ultimately to answer this question down here, the grams of excess reagent. So to find limiting reagent, we can compare moles of aluminum and moles of iron 3 oxide by just using those mole ratios. So I use that mole ratio to say, okay, for every 2 moles of aluminum, right, I need 1 mole of iron 3 oxide. So basically, in this reaction, I'm going to need 0.8895 moles of iron 3 oxide. Well, I'm in luck. I'm in luck because I have, right, this is what we have. I have 1.4. So I've got more than enough iron 3 oxide. So to find the excess reagent, right, to find the excess reagent, right, okay, I have 1.4, 0.8895 moles, right? This is how much we're going to use in the reaction. So I subtract those two, right? 0.5195 moles of iron 3 oxide in excess. That's what we have. So sure, I'll answer the last question first, right? Well, I can turn that into grams by saying, well, it's 159.69 grams per 1 mole. So it's like 82.95 grams. So we'll call that, right, 83 grams of excess iron 3 oxide. We know the limiting reagent, the limiting reagent's aluminum, right? We found the excess reagent as iron 3 oxide. And the last thing we have to do is to find grams of aluminum that can be made, aluminum oxide that can be made. So, well, I had 1.779 moles of aluminum, right? For every 2 moles of aluminum, I'm going to make 1 mole of aluminum oxide, right? That's my limiting, that's where the reaction stops, that 0.8895 moles of aluminum oxide. Can't do anything with moles. I need to find mass. I bring in the molar mass, 101.96 grams per 1 mole, right? For like 96.9 or 0.69 grams of aluminum oxide. So again, I think it's maybe decimal places here. Yeah, Mike, let me just finish this and I can take a look at what you said, right? Usually when I'm doing the calculation, I do the ratio with aluminum in the product and also, so also half, but that's also, but is that wrong? No, that's fine. That's like the normal way. If it was just a regular limiting reagent calculation, that's what I would do. I would convert both of them to aluminum oxide and compare both of them. The only reason I did it this way, to convert them both to iron 3 oxide, is because of this fourth question down here. It wanted us to figure out the excess reagent. So that's why I converted them both to iron 3 oxide, so I could compare those molar values, subtract them, and then find out how much excess iron 3 oxide I had, so that I could find out how many grams of excess. But yeah, your way is totally fine. And you always want to pick the same one. So if there were 2 different products in this reaction, which there are, you just want to convert to the same one. So you're comparing, right, identical units. We don't want to convert one to aluminum oxide and the other one to iron, because then we wouldn't have the same units. We want to convert them to the same one. Yeah, so question 10 was a good one. That was involved. We want a quick request for question 9. And I don't know, Caitlin, we've got 14 minutes left. Right, this reaction, nitrogen plus hydrogen yields ammonia. And if I tabulate everything, we've got 4 nitrogens and then 1, 2, 3, 4, 5, 6, 7, 8, 9 hydrogens, right? So the molecule is the limiting reagent. So for this reaction, for every right, what molecule is limiting reagent? So for every 1 nitrogen, we need 3 hydrogens, right? So, okay, here's 1 nitrogen and 3 hydrogens. Here's 1 nitrogen and 3 hydrogens. And then here's 1 nitrogen and 3 hydrogens. So what's the limiting reagent? I would say hydrogen is the limiting reagent because we have excess nitrogen, right? That's question 1. What molecule is in excess, right? Nitrogen must be in excess because we had extra nitrogen, and then the excess molecules will remain. Basically, one nitrogen molecule will remain, right, at the end of that reaction for question 9.